I think that was the talk was a perfect prompt for what we're going to try and discuss now, which is, and I think that, echoes Karthik's prompt here, which is that the structures that we have to do this are insufficient. And so what's the radical new structure that we could possibly have here that could allow us to do the kind of big science, right, that Jason laid out. And so in preparation for this, I was trying to find a more recent version of something that is extraordinarily ambitious that was done in a very short period of time. And so thanks to Vinod and Rajesh, I was able to talk with Patrick Su, who co-founded this institute called the ARC Institute. And probably many of you have not heard of it. ARC Institute was launched about a couple years ago with this unique structure. It's a nonprofit, 501c3, which collaborates across a variety of universities. And they started with a $700 million corpus of capital to go after really challenging problems in biomedical engineering. Okay? And they had sort of multiple pillars and so on. And they're a year and a half in, right? They have gone to about 100 people. And one of the main things that Patrick said was that the key element that they now in hindsight realized was the crucial piece to be able to scale so quickly was the leverage that they had with being able to access the human capital that the universities offered, right? And I think that's going to be a critical piece, right, as we think about this. And so the question really is, could we, within a few months, pull off a similar effort, right, in order to build an ecosystem where we can cut across institutions. And the most important thing there is that it's an entity that cuts across institutions, right? And institutions both from academia and then labs and so on. So I think, I could not have, a more distinguished panel of people to talk through this, right? So the agenda here is we're going to try and cover three pieces, right? Ecosystem, funding, and then sort of how the sort of various pieces talk together. So I'm going to start by having each of the panelists open up with a couple of minutes of opening remarks, and then we'll flow from there. So I guess I'll start with Al.
Sure. Yeah. Thank you. So you all know me. I'm Al Hero. I was on the previous panel representing University of Michigan. I'm now representing National Science Foundation. And so my comments may be a little more guarded than before.
I'll make it up.
So the National Science Foundation has placed enormous priority on AI for science and AI foundations. And this is represented by the many different programs that the NSF has put together in the past 5 years. These include the AI Institutes, which is a $150 million enterprise. Actually, quite a bit more than that. I'm off by an order of magnitude, $20 million each institute, and there are 28 institutes. Also, we have invested in particular in this to try and bridge the gap with the workforce issues. As you might guess, the majority of AI institutes are awarded to what are called Carnegie R1 universities. Those are universities that are well-funded from the government, different government agencies. They correspond to the cream of U.S. National prowess in academic research. What has been left behind are the universities that may be Carnegie R2 or no designation, that are just not in the in the envelope. They're either teaching universities, they're universities in states that don't have a lot of research funding going to them. And so there's very recently, there's been a major effort to fund these universities, a program we called Expand AI, which can either be in partnership with AI institutes or else independently. And this is, an effort which I think goes in the right direction for trying to address these broadening of participation and workforce issues, which I agree are extremely important, arguably more important than the science itself, because that's the next generation that we're investing in, and the talents of the next generation will determine whether we fall over that cliff or we are able to expand and make progress in AI across the board. Let me stop my comments there. Lots of other programs I'd like to talk about at NSF, but I'll stop there, and I will hopefully get the chance to introduce those later on.
Of course. And thanks, Jean-Luc.
So I don't claim to represent the DoD. The DoD is a huge place, but I do claim to represent the Basic Research Office at OSD. And our mission is really to fund and oversee all the basic research that is funded by the DoD. Basic research means basically that, what academia is doing. And I'm here because there are several questions that I have that we need to find answer. One of those is, what does fundamental research in AI look like? And by that, I don't really think that what the big companies are doing is fundamental research. We're looking for something that is very different, very disruptive. And we need to do that because academia cannot compete with the big companies. So that's the niche, basically. And what it looks like, I'm very eager to discuss what possibilities. The other question is about the ecosystem, is that who should do that basic research? Obviously, it has to be academia in partnership with national labs, and other labs. The industry may have a role. That is something that is not clear to me. The other question is, what can we do to change the ecosystem? Should we change the ecosystem? I think we should, but changing the ecosystem, and it's one of the questions we have here, is that it's going to be extremely difficult, because if the trend is to go towards extremely large amounts of data, but there is no limit to it. We can scan documents after documents all the way down to the scrolls of Alexandria if we still add them. But that, there is a limit to that, and there is a limit to how much resources we can put that. We can never match a $100 billion supercomputer. So we must find another solution. And finally, something that is very important that Jason alluded to is the security aspect, is that we have AI that is supposed to be general AI, that has transfer knowledge, and some people at the companies claim that, we're going to make everything open. Okay, but what does that mean? If you use AI in scientific foundation and use it for scientific discovery, that would mean that we're not telling anyone else how to invent something. We're telling them how to have a tool that invent lots of things. And is that a good idea? And that means that at some point we have to make a decision. And we're all in favor of the Bush Pact. The Bush Pact is incredibly important. Open research, fundamental research, these go together. But at some point, what happens? And that is absolutely not clear.
All right, thanks. Jason?
Last week, was it last week? I've been traveling a lot. Last week at the Bush School in DC, we had a conference with some of the laboratories and a number of universities. And the question of that conference was, how do we work together for the future? And something that struck me from there was there actually is a lot of low-hanging fruit, things that we have the freedom to do together now. We can create collaborations on data and find common principles for them and put them in the same place and all of that. For probably the next year, the movement of the community is going to depend not on what any one giant does, but on what we ourselves do. So the lesson I took from that was there's a lot of great ideas that are just sort of waiting to be tapped. And I'd like to make the invitation to the very thoughtful people here that if you see an opportunity for doing something smarter or creating a new structure or something, please write me or Ian, or let's see if we can just get it done. Yeah.
Yes, hi everyone. First off, thank you Kartik and Venkat for the invitation. I am Alvaro Velasquez, Program Manager at DARPA, where I manage the sort of neurosymbolic portfolio of investments. But most recently, I've been focused on scientific discovery. And so I want to talk about, at a lower level, some of the interesting problems we're looking at, and then I'll sort of zoom out as to what potentially an ecosystem might look like across academia, funding agencies, and industry. So one of the things I've been mostly focused on is how can we do scientific discovery in domains where we don't really have the fundamental building blocks or the inductive biases by which we can reason about new scientific theories. So for example, with materials discovery, it's very common to have DFT, density functional theory. This is a very good inductive bias. For protein folding, we have we know the electrochemical properties that dictate what a valid protein folding is. We know what the van der Waals forces are that govern the physical dynamics of proteins. And so we have very good building blocks or inductive biases. But if you want a truly general scientific foundation model, in principle, it should be able to discover these inductive biases on its own, even in domains where we don't have that much knowledge. So for example, could we train a foundation model that can read the research literature, tap into PDE solvers, tap into simulations, and identify the inductive biases, or perhaps discover it through experimentation? So that's one of the big problems. This is a challenge that arises a lot in areas like metamaterials as opposed to materials, where we have to reason about the mesostructure, composition, and it's harder to just use existing inductive biases. This arises in climate modeling, it arises all over the place. So that's one problem we've been looking into. The second problem, and we've had echoes of this over the past 2 days, is how do we actually quantify creativity and hopefully turn it into a trainable form? Because, you know, by definition, if you have a very creative hypothesis that is being generated by your model, it was likely not in your training data to begin with, otherwise it wouldn't be that creative. It might even invalidate some of the theories in your training data. So how can we generalize to such a creative hypotheses? That's sort of the second big question that we've been looking at. I would also like to note, for folks in this room might be interested, there's a new program called SciFi. Proposals are due at the end of the month. It's on scientific feasibility. So if you look up SciFi DARPA, you'll be able to find it. And so those are some of the tangible problems we've been looking at DARPA. But more broadly, going to the ecosystem question, I have conflicted thoughts about this. So in the short term, absolutely we need to scale up. I mean, I think we're all in agreement. We need to, we need to make it easier for academia to be able to scale to a reasonable level to tap into the powerful methods, the powerful architectures that industry uses. But in the long term, I think the beauty of academia and the funding agencies is that we can take greater risks and we can reason about what it means to completely upend these scaling laws. You know, we're in a predicament right now because big tech companies they have perverse incentives to keep the scaling laws going. You know, if you look at Google's Gemini, I believe it's 1.6 trillion parameters. I can't imagine what it takes to train this thing. Clearly, none of us in this room could pre-train Google Gemini. We don't have the funds, presumably. And it's in industry's best interest to keep it that way. So really, we should be researching how can we create much, much smaller models? How can we completely upend the scaling laws and really level the playing field for all performers, for small businesses, for academia? You know, we can't have these AI gatekeepers. That's in the long term. In the short term, I know I'm not an idealist, I'm not naive. I know in the short term we need to scale, but I want us to keep that long-term goal in place. There's a lot more I could say, but I feel like I've been rambling on for a while, so I'll leave it at that.
Thanks, Alvaro. John?
All right. Hello, everyone. My name is John Wei. I am investment director at Applied Ventures. Applied Ventures is the corporate venture arm for Applied Materials. For those of you not familiar with Applied Materials, we're the largest semiconductor equipment and also display equipment maker. So if you see all the semiconductor fabs with all those machinery that used to stamp out chips in H100, et cetera, a lot of those machineries are made by Applied Materials. As part of the venture group, our investment focus is really up and down the value chain of semiconductor manufacturing, from materials to processes, equipment, tools, and all the way down to new compute infrastructures, both hardware and software. At Applied Materials, we proud ourselves as being sort of able to do extreme material engineering at industrial scale. So as you can imagine, you know, you need to precisely etch a trench on a chip, you know, sub-nanometer, even approaching sub-nanometer scale. You have to be really precise. You have to do this hundreds and thousands of times in order to make a chip. So how do you do that? So there are tons and tons of material challenges as well as physics challenges that our engineers and scientists are constantly dealing with. And that's why, you know, we see this scientific foundational model as a really critical tool, I think, that would help us enable our engineers and team to continue to push the boundary of material innovation. So really grateful for the invitation to join this conference. I learned a lot, and I look forward to interacting with the community here. Thank you.
Thanks, John. Jonathan?
So first off, I guess I should make it clear I'm not representing the Department of Energy, and I have to, like Jason, be careful, I guess, of some of the things that I say. I thought it might be instructive maybe to compare a future AI initiative with what happened with the exascale computing project, and to maybe illustrate how much more complicated the current situation is. The ECP flowed out of something called Exascale Computing Initiative, which was decided at the federal level, where basically the funding agencies and other parts of the government got together and they kind of decided how the whole necessary set of thrusts to make it a reality would be divided up. And then it was kind of a logical place for the national labs to house the first exascale machines. And then the labs reached out to university partners to do the work in making that a reality. There wasn't the tension, the political tension, this kind of nation-state geopolitical issues around exascale as much as there is with AI. Also, the relationship with the vendors is a lot more complicated now. So there were basically two kinds of vendor relationships with ECP. There was the relationship with the vendors who were going to manufacture the exascale machines, and then there were a downstream manufacturing companies or engineering companies like GE, like United Technologies, who would be able to take some of the products of the exascale computing project and use them. So those kinds of two relationships. Now, has been pointed out several times today, we have commercial actors who have resources both in manpower and in computing, which far exceed the situation that was the case in ECP. And finally, I guess it's the scale of the teams. If you look at some of the author lists on some of the recent LLMs, you'll find more than 1,000 people at Google, maybe even 2,000 people. And that's an order of magnitude, maybe 2 orders of magnitude in some cases, of the teams that we assembled in ECP to put together various components of the stack. So we really are going to have to think afresh about what this compact is between universities, between commercial actors, and with the national labs, and figure out a niche which is both workable in that sense and convincing politically. I'll leave it there.
Right. Rajesh, to close it out. And before you start, so Khosla Ventures, turns out that they made the first private investment in OpenAI. It was the largest investment by Khosla Ventures. It was $50 million. That was the first money into OpenAI as they transitioned from nonprofit to for-profit. So we're very glad that Rajesh is able to hear.
For me, the Khosla Ventures, I probably have the lowest chance of getting fired for anything I say controversial. Maybe a quick show of hands. How many of you are students here? Impressive. Professors? Industry, big companies? And investors? Very few. That's a good thing. You're not in a bubble then. So, just at a high level, I've been with Khosla Ventures for 5 years now. Yes, we were the first institutional investor in OpenAI, put a $50 billion check. About 5 years ago, it was at a $1 billion valuation that's grown very well. But more importantly, for 18 years, we've been investing in hard tech, deep tech. We have invested in companies like QuantumScape, solid-state batteries. Venkat has been an advisor for the company. Things like sustainable aviation fuels. A poster child is LanzaTech, kind of 15 years in the making. Companies in precision fermentation, pharma, a lot of that stuff. So if you think about how long it has taken many of these companies, these have all been kind of overnight successes, 10, 15 years in the making. And the beauty we are seeing with AI, we invested 6 years ago, so we have a lot of companies, not just on the AI side of things, but AI across multiple verticals. So we have companies across, weather prediction, pharma, self-engineering, all of that stuff, and happy to talk about some of them later. But the whole thing is moving much faster because of what AI is doing. My biggest worry is, I've been in 4 industries. I was first at Bell Labs, so still have some engineering pedigree, material science, so don't hold my venture capital experience against me. So being at Bell Labs, one of the 4 industries which did not stay in the US and significantly went to Asia, China, right? So telecom, we used to joke about Huawei, whereas Bell Labs or Lucent don't exist anymore. Then I was at heading Applied Ventures, the venture arm of Applied Materials. Semiconductor, a lot of things started transitioning to China and so on and so forth. There's a lot of effort to bring chips out internally here. Then even at Applied, we did a lot in solar. We had a company called Bacchini, which was silver printing. Very soon, during travel to China, we saw a company called Bikini, right? And then battery was the other industry. Now we are all trying to bring that back. 4 industries. And my biggest worry is AI is going to be another industry, which is going to be very big, and China is moving much faster. So if there is any takeaway from here, it's like, how fast can we move? It won't operate at the pace we have been operating. A lot of friends in national labs, universities, and all that stuff. People just are struggling under the bureaucracy in terms of how fast we need to move. So I'm glad to see a lot of students here. I think the only way we'll move faster is create a lot more startups, work really collaboratively with big companies, national labs, spin out ideas, and make some of these things happen at a much faster pace than what we are all looking at here. And happy to chime in more and add.
All right. Okay, great. So I'm going to try and follow Karthik's format. So I'll ask one, and then audience one, and then we'll keep going. Oh, sure.
One extra, I didn't mention anything in my introduction about the ecosystem, but I did want to make everyone aware that there's very recently a direct result of the president's executive order, a new initiative which is in pilot phase, which is the National AI Research Resource Initiative. That is in collaboration with many different federal agencies, including DOD, DOE, NIST, and so forth, in addition to a large number of the major big players in industry like Amazon and Google and so forth. So while this is a baby step forward, the NAIR initiative, which is now in its pilot phase and is accepting proposals for basically compute cycles. But the vision is that it becomes a national resource for a repository of code, of data, of expertise, consultancies with the national labs, with other entities in industry and so forth. So I wanted to mention that to give a little bit of momentum to things that the U.S. is doing currently in order to try and jumpstart that ecosystem. It's not a lot of money currently, but it's a start.
Okay. Great. Let's start with the ecosystem. So we want to try and do one-third, one-third, one-third. So ecosystem funding, and then we'll close with venture and startups and innovation. So we'll start with what is the structure of an entity that could pull off whatever Jason was outlining in terms of gaps, and I think all of you have sort of articulated various ways. Does anyone want to venture a guess of what kind of structure might one want to pull off in the short term?
I think, so from the DARPA perspective, there's one that makes a lot of sense to me. In terms of what we call FFRDCs, federally funded research and development centers. So at DARPA, it's our funding structure, it's very common that we have, these 3, 4, 5-year-long programs. It's very different from NSF with a particular goal and some kind of test and evaluation team, which is usually the FFRDC. So this would be MIT Lincoln Laboratories, CMU Software Engineering Institute, etc. What I would love to see, and I don't know the logistics of this, is if we could have something like NVIDIA be an FFRDC. Because then the industry collaboration and compute would be baked into our investments directly. Right now, if I want to fund an FFRDC, they're still asking me for compute. They're still asking me for X amount of money to buy A100, H100 clusters. They're actually very limited, obviously, when compared to places like NVIDIA. So I think that's one tangible thing that could be done. I think there are maybe generally at least 3, maybe not sufficient conditions, 3 necessary conditions for this ecosystem. And I think maybe it's worthwhile to think of this in terms of necessary and sufficient conditions. One of them is the multidisciplinary angle. When we're talking about scientific discovery, NSF has these beautiful long-term portfolios in the fundamental sciences. DARPA has these short-term goal-oriented portfolios, and industry has the compute. I think it's a necessary condition that we marry these 3 things, that we get the multidisciplinary angle from NSF, we get the goal-oriented programs from DARPA, and the compute from industry. And I think bringing in places like NVIDIA as an FFRDC is a good starting place. I would also be curious to hear if there's a VC angle here, because it's very common throughout the life cycle of a DARPA program that people will branch off and start their own companies based on the results that they conducted during that program. So maybe in the late phase of these programs, there could potentially be a sort of VC angle. I would also be curious to hear from our OUSD representative what having NVIDIA as an FFRDC might look like, because typically it's OUSD is a co-lead of these FFRDCs, so they understand the logistics and the process better. Those are my 2 cents.
I like the out-of-the-box thinking. It's a great start.
Yeah.
Yeah, so, there are FFRDCs that are doing great jobs. They're doing great jobs in applied research and testing and validation and things like that. To bring NVIDIA into the FFRDC, I don't know if that is possible. I think that partnering with the DoD national labs would be a way to solve part of the compute problem. I think that that would be great. But I think that I want to emphasize also that we need a very diverse ecosystem. And diversity is actually a strength in the US. The diversity of agencies, we not have one person doing the wrong thing. We have lots of agencies, we fight against each other, which is great. And that's how things get done slowly, I admit. But I think that's a good way to have it done. And that means also diversity of portfolios. We can have DARPA, we can have, the DoD, DOE labs, et cetera, and we have small grants to universities, the YIP grants, just for people in postdoc to get started, and also the faculty to push their ideas. I mean, the diversity is extremely important. We have to keep it.
The world of climate, there have been what DOE has created hubs, like a hydrogen hub and a direct air capture hub and a bunch of other things that work really well because it forces the industry labs in a given ecosystem to come together really and compete for some large grants. The good thing with AI is so interdisciplinary. It doesn't have to be a physical hub. It could be a digital hub that forces, somebody in CMU or somebody in Michigan to work with, somebody in California or NVIDIA and really form a consortium where you look at the centers of excellence in each area. Some university, I think Berkeley is really good at MOFs. Here, you have Venkat and a lot of other people, you guys are great in batteries, right? So figure out what are the right consortiums to come together to make a huge impact in an industry vertical. That could be a big success in terms of how you pull this together and be motivated to move fast as well.
Cool. Yeah, Karthik, you have a mic. Okay, go for it.
So I have a question. It's also maybe a comment. I think it's also not just for the panel, but for everyone to think about. So universities are built to collaborate, right? Most proposals we write are with partners all around the country, sometimes even international. So I don't think that by itself is an issue. But what we're talking about here is different. So what kind of new structures can we envision within universities, right? So we usually say sometimes when it's convenient, we say we are part of the Big Ten, right? Is it possible to create structures where faculty are movable within institutions, across institutions, share resources, students share significant chunk of their time and not, chop it up. Maybe there is something to do. I don't know, somebody pointed to, there are some things even within this structure that we can try to move. And the other thing is, what can we do to incentivize failure? What can we do to incentivize fast failure, right, from the national labs and from government agencies? And also, how do we encourage people to try things? And also, how do we assign value to things that are traditionally not assigned value, right? Like validating a result or improving a data corpus or probing. So again, this is a more general topic, but I'd like to see some opinions here so that helps us write the vision.
I'll start quickly. The problem you describe is also a problem.
Yours.
Yeah, I mean, the problem you describe is a problem we also have with the semiconductor industry, how to innovate in the semiconductor industry. And I think that what you describe is important, that we need a lot of exchange between all parties. And the academic framework is very good for that because there is an openness to it. And then if there is a need for making something a bit more restricted at some point, then it can be done. Yeah, I think that there is no simple solution, and as you say, it may depend on the domain, but you have to focus on domain, basically, and then have another one that may be on a different domain.
I would say break the silos. If you're a mechanical engineering student, for your next project, don't work with anybody in mechanical engineering. Work with somebody in computer science, right? That's what is more important. That's the beauty of everything that we talked about in AI in terms of scientific foundation modeling, because you don't necessarily have to be a domain expert. You need to have the right domain expertise, but this one breaks all the barriers in terms of what all you need to have. So breaking the silos even within an organization, within a university is a lot more important than actually just working with somebody outside. And as an example, Stanford has just to take one example, Climate Ventures class. I think, Venkat, you might be familiar. Thinking about, there was a statistics, that particular class has been there only for last 7 years. I think about 75 projects came up, 47 startups got started, about $750 million was raised on those companies. And those are some really good companies. Like it just boils down to 3 or 4 professors really taking the effort to see, I want to think big about what's happening here, and I want to make a big impact, and what kind of class and pool of candidates am I going to bring together? It's not going to happen in the first year in terms of huge success, but it takes those 3-5 years to make it happen. That will make a huge difference to the universities.
Yeah, actually, we have a couple of people from that class that have started these companies that are in the audience.
Great.
So I think we've covered a lot on the ecosystem. I want to talk about funding because I think there are some numbers that have been put out, right? So what's the scale of resources needed? And I think there's 2 numbers, right? The hub, right? The hub was a $120 million over 5 years type of investment, and then the scale that Jason mentioned, right, is a few billion, which was considered too low, right, by Jean-Luc. So what's the scale needed, right, in this coordinated effort? How should we think about that? And what fraction of that is personnel versus compute? Any thoughts there to kick us off?
It's funny. It was maybe a little over 2 years ago that we first began talking with Congress and others on the scale of the effort. And at the time, we would sort of quietly say $2.5 billion. It seemed like Dr. Evil, infinite amounts of money. And then as time has gone on and the picture of the scale that industry is investing has emerged, it's like just this tiny number. It seems completely inadequate. One way of framing, I think there are 2 ways of framing the question of scale, and I'll just talk about one of them. Well, I'll mention one and then talk about the other one. One way of understanding scale is to be really clear about the audacious goals that we're aiming for. Especially with the technical community, they have the wisdom to say, man, this is all really hard and the chance of failure is pretty high, and so let me talk about like the next 2 steps, but let me be quite honest and reticent about the, like, say, completely transforming science or human level AGIs for science or that sort of thing. But we're going to need to frame those big goals and have just be clear on them. So finding the Higgs was a big goal. They might not have done it, and that was going to cost $10 billion or whatever it costed. Fusion at ITER is a big goal. They may fail, but it's a $10 billion goal. So I think we as a community need to be less shy about being audacious. But that's the part I'm not going to talk about. There's a really basic question, which is, are we talking about a perturbation to our past practices, but then everything just continues as it has over the last few decades? Or are we talking about a kind of foundational rewiring of the nation? Are we talking about a future where every scientist has access to $100,000 worth of compute a year, because otherwise they're just not nearly as productive as they could be? And then my own answer to the second question is yes, but people may have different views. But if you answer, depending on your answer to that question, it really sets the scale and causes one to think about it in a different way. Yeah.
I could say also that critical is not, that we have funding programs that strike a balance between what has been very successful in the past from many funding agencies, which is single investigator types of investments, versus those very large or moderately large multiple investigator types of projects. I personally think that there are advantages to both models, and we should not minimize the value of individual projects that may be only addressing one perhaps fairly narrow question, but that can have unanticipated, much broader consequences when it comes through. I mean, compressive sensing is an example. When Emmanuel Candace applied for his compressive sensing funding, it was he had a small idea, but it ended up effectively revolutionizing many technologies, in particular magnetic resonance imaging. So I just wanted to make that point. I also want to make the point that big programs are very laudable and good to look forward to and hope for, but it might be more successful in terms of at least the short term to try and invest in smaller scale programs that are more targeted. And so there are two programs at the National Science Foundation that have recently been released, and the solicitations are out right now. One is relevant to the automated AI-assisted mathematical reasoning. It's called Aiming for Short, which is out. There's a webinar. Anyone who's interested in applying for funding in this area, which Sean was discussing earlier today. It's a small program. We're anticipating maybe on the order of 10 to 12 proposals per year over 3 years being funded. But it's aimed at really trying to disrupt the role of AI in the science that we call mathematics. And so April 11th, next Thursday, is when that webinar is. So if you just Google the NSF AI for formal methods and assisted mathematical reasoning, you'll get a hit. The other program I want to mention is a program that's come out of SAIS, my division, which is the Accelerating Computing-Enabled Scientific Discovery, the ACE program. Again, we're accepting public proposals now, and that covers a very large swath of AI for science and scientific discovery that touches upon everything from digital twins to reproducible research to many other areas. So these are small programs, relatively small programs that are more targeted and that are relatively easy to push through because they're kind of under the radar. They don't require a national initiative. But again, maybe looking at trying to raise the pressure from the grassroots, that is you out there who are clamoring for more resources and are successful in getting these perhaps a little less ambitious projects, but producing results that very quickly make transformational changes to society or science or health or what have you. That will certainly go a long way to moving public opinion. Hopefully, I'm an optimist on that. But,
Okay, let me try to bring the audience in. Anyone wants to question, comments on the sort of funding side?
Thank you, Venkat. So as I think about the various issues that all of you have raised, it seems to me that there are actually quite separate things that can be addressed. They're related but should probably be addressed individually. So there is a question of the human capital. And for that, yes, there is a sense of urgency, there's a question of scale, but as Al was saying just now, I think that the processes we have in place are probably just fine. It's a question of just, if we push for the investments, it'll happen. I don't think anything special is required. In terms of compute power, we have a significant issue. We've got the TPC as our one attempt to try to do something, I guess in the NAIRR. And at the current time, I think that these are, what I would really hope is that we can have a conversation about how we can really accelerate these and grow these, because this is something that is, I think, important steps in the right direction, but we need a lot more. And that's where collectively I think the people in this room can have a good conversation. And then the third thing is sort of the national, where's the industry going, and are we investing enough in this, and so on. And that, I think, is a really important point that Rajesh made. I'm not sure that the people in this room are the right set of people to address that question. It's a segment of the society that needs to do that. And I think motivating the people in this room to think about this and having that conversation or starting that conversation would be great. So, thank you.
Yeah, thanks, Jack. Anyone wants to comment? Actually, this also ties into a question that I wanted to cover on compute inequity. And I love Jason's point about you start your graduate school and then you get a $100,000 compute credit to go along with your admission letter. I think that's a nice way to think about it. So yeah, care to comment on any of these aspects?
Actually, the point you raised about needing to accelerate our efforts in TPC, which to the broader question of an ecosystem, we have a great example of how to do it out there. My own view is for that, there's other classes of problems, but my own view is for that class of problems, let's all just do TPC. We have something that's working, it's quite good. We could maybe make it better if it needs to, but it's really quite good. It was mentioned that for that, we're having the trouble of staffing what are some super important but pretty boring functions. And high energy physics probably has a lot to teach us, because there, to make a particle accelerator experiment work, you just need all kinds of specialized functions, some of which don't look like discovering a new particle, but they're absolutely essential. If you don't do them, you don't discover that particle. It seems that that's a definite way we could consciously try to change the value system so that we can get recognition and staffing at the scale that we'll need it for these things.
I have to respectfully disagree on the process side of things. I think we have a great process to innovate and invent things, but we have a terrible process to actually build an industry here. Otherwise, we wouldn't have lost the 4 industries I mentioned about. So that's where I was saying we need to move much faster. Just existing processes are not sufficient because we are creating the value, but we are not capturing the value. And I have to respectfully say the audience here can make the difference. The kind of companies we are investing into are coming out of Stanford grads, MIT grads. I have invested in a couple of Michigan companies. So those 1 or 2 people can make all the difference, right? And we need to take that into account when we think about how can we make a difference.
Okay, we're almost, we're already like 7 minutes over normal time. So I get yeah, go for it.
Try to keep it short. Yeah, of course. I made some notes. Sorry. I'm going to read out my notes. So I do feel that if many government agencies and universities are going to unify under a common umbrella, this is a gargantuan project. And I've led many software engineering projects in big companies. And project management is messy. You're talking data here, you're talking API, you're talking documentation, you're talking model management, model registry, auditability, trackability, documentation again, compute resources, APIs, common APIs across everybody, because you don't want people to innovate and create APIs. And also at that point in time, this is a gargantuan project. Because there is data is messy, you need to extract, transform, load, clean up data. This is massive, huge effort, and this is going to, unless there is light touch in it, people would come and people would go. And there would be just collaborations from agencies to agencies and not at a government level, I would say. This has to be super light touch.
I think we're all in agreement.
There are 2 more questions that I want to try to get to.
I can comment quickly on that. I completely agree. And so before I was at DARPA, I was with the Air Force, AFRL. And the way we managed that is we had it was sort of controversial, but we had a software engineering company that basically turned this sort of pipeline from the novelty that we produced in the lab to actual useful products. So if we were to pursue this large collaboration between, say, NSF, DARPA, NVIDIA, we would need a similar such pipeline with professional software engineers. I have no illusions that our scientists that innovate are also the engineers that are capable of documenting everything. We all know there's a trade-off.
All right, last two questions, you and you. Yeah,
So
Alex, go first.
there's been a lot over the past few hours about how compute needs of these models has just grown exponentially, and that pace is super important. But what I haven't necessarily heard a lot about is the pace at which the hardware behind that compute has also been just absolutely phenomenal. When I started, we have a bunch of K80s at our cluster at CMU. Now Access, we mostly have V100s. Of course, that's 2 generations behind the current technology. We've gone from A100s to H100s now. And in terms of the memory capabilities of those GPUs, they've gone from around 12 gigs all the way up to 80. And that enables massively large models. If we want to get to these bigger models, so the Frontier paper about training at exascale shows that they can basically only go up to, I think it's about 4 to 8 GPUs in terms of model sharding before just pipeline parallelism breaks down. And so what I'm basically asking is, as we build these new clusters, as we accelerate that, how do you keep up with that rapid pace of hardware if the machines that get built are going to not necessarily be able to keep up with the Frontier in a very short amount of time?
The lab folks.
I would give it to the NVIDIA folks there. Would
I'd like
also
to-
give it, yeah.
If we could invite NVIDIA to give an NDA level product roadmap.
Yeah, okay, last question.
Okay, so that works. Thank you for your comments. The last question, I guess, would be related to startup and innovation. Rajesh, sorry if I pronounce your name wrong. You mentioned how to capture that value, and so I'm wondering what kind of what business model do you envision to work for the future for smaller entrepreneurs or students that are going out of school, being able to capture that value against OpenAI maybe trying to do this? To get the analogy of one of its co-founders, he mentioned some kind of LLM OS that is being created. If we cannot be the infrastructure and we don't want to be the one that competes to be around it, what would you suggest?
Very critical question for AI, because we look at a lot of combinatorial chemistry companies like molecule discovery for drugs, or finding the next set of metal organic frameworks, or all kinds of materials, particularly for discovery. Our view is you have to go all in to make it. Otherwise, you're licensing the technology, you're making incremental innovation. Yeah, and some big company will buy you, but you're not changing the world yourself in a big way. And every VC thinks about differently. Our view is you have to go all in and make the change you want to see yourself. And if you have the right backers, right early development, right partners to support you, you can make it happen. But this is a very critical question that a lot of companies go through. And sometimes,
just add a real quick, a few suggestions for the technical folks here. I would encourage every student to pair up with somebody at business school, MBA students, to, oh, you are, okay, to really work together and always ask yourself, how do I make money? That seems to be really the question that I think a lot of technologists need to ask themselves. Over the last 2 years, the last 2 days, I'm listening to a lot of the amazing talks about technologies, about the innovation. In the back of my mind, I used to be a PhD in technologies, but I've been trained enough in the VC field to always ask myself, how do I make money off of this technology, right? And also the other point, I think, you don't always have to go after OpenAI or some of these big mega sectors or big players. There are, in the VC world, we talk about plumbing layers. So in the Gen AI stack, there's so many things that need to happen as you grow this whole industry forward. There are a lot of things, tools, and basic things like data management, security, basic things that need to be in place. And in order for you to have a fully functioning AI, Gen AI economy. And so find a niche layer that you can find repeated customers that you can honestly to yourself to say, okay, this is going to be a $1 billion company, a unicorn company. Does not have to be hundreds of billion. $1 billion is good enough. So that would be my suggestion.
On that billion dollar note, I want to thank the panel for an extraordinary perspective. And I think it's really inspiring to hear everything, the diversity of opinions, perspectives, and I think we're in a sort of unique moment in history, and I think it's one that I think all of you can help change the arc of history. So thanks to the panel for their engaging discussion.